Right, grade 12, let's look at some further examples on tangents to curves. And this example is determine the equation of the tangent to this parabola, which is parallel to the line y equals x plus 2. Now what I'm going to do, let's just sketch these graphs to see what is actually happening. We want to find the equation of the tangent to this parabola, which is parallel. There's a key word, parallel to the line y equals x plus 2. So if we take the little parabola graph, let's have a look at how would we sketch this graph. Well, the y-intercept is most definitely naught, because if x goes naught, well, the whole thing goes to naught. The x-intercepts, let's see how this goes. Okay, we're going to let y be equal to naught. Okay, so let's bring those across and let's see what our x-intercepts are going to be. It's good revision of actually sketching graphs as well. So x is equal to naught or x is equal to 3. Alright, so there's the x-intercept, the turning point. Well, what we could do is we could simply get the derivative, if you like. Fx is equal to, it's one way of doing it. There are many other ways. I like calculus. So let's get the derivative. That is negative 2x plus 3. And then at a turning point, what do we know? The gradient is equal to naught. So let's plonk it equal to naught, bring that across, and we get ourselves a little bit of a fraction. That's 1.5. Okay, and then the corresponding y value, well, no problem. What is the f of 3 over 2? Would be negative 3 over 2 squared plus 3 multiplied by 3 over 2. So what's that? Minus 9 over 4 plus 9 over 2. And we can tidy that up. That gives you negative 9 over 4. If we multiply top and bottom by 2, we get 18 over 4. So negative 9 plus 18 is 9 over 4, which is 2.25, if you like. So the turning point would be at 1.5 and 2.25. Okay, and we could then draw the graph of this parabola. So let's do that quickly. Let's get a set of axes, and we can then easily plot that. Here we go. Now what do we know? We know that the parabola is cutting at 0, 0, which it does beautifully there, and the other x-intercept is 3. Let's just double check that. There's 3 there. Yeah, there we go, 0 and 3. Great. Y-intercept is 0, which is great. The turning point is at 1.5. So if that's 3 there, so that would be 3, and that's 0. What would that be then? Okay, that's going to give us 1.5's about there. So let's go up to 2.25. Don't have to be accurate. 1.5, 2.25 there. And then the parabola would, of course, go like this, comes up, turns at 1.5, 2.25, and down we go. And there's your graph of your parabola. Now, what about the line y equals x plus 2? The line x plus 2, this guy here. Let's draw him quickly and see how it relates to the parabola. Okay, well, if you've got y equals x plus 2, well, the y-intercept is 2, so if we look at that, it's going to be somewhere over there. Doesn't have to be perfect. In fact, we could maybe take it up, but in fact, let's take it up a little bit just for fun there, because there's 2.25 there, so it's probably about here to be more accurate. And so the y-intercept is 2, and then the x-intercept, we're going to let y be equal to 0. So if 0 is equal to x plus 2, then x will be negative 2. So we're cutting about there. Okay, and then there we go. So we've got our straight line here, which looks something like this. If we draw it in, y equals x plus 2. Okay, now it's not touching this line, y equals x plus 2 is not cutting the parabola at all. But what we do know is, if you think about it carefully, and I'm going to go to a different color here, is that we want to find the equation of the tangent to the parabola, which is parallel to this line. Now have a look at this. If you take a tangent that's running parallel to the line y equals x plus 2, look at that. There's our tangent. It's cutting the parabola at that point. I don't know what it is, but it's running parallel to this line here. And parallel lines have equal gradient. What is the gradient of y equals 1x plus 2? The gradient is 1. So we know automatically that the gradient of the tangent is then 1. Okay, now the question is, to enable us to determine this equation of the tangent line, we're going to need the x and the y. We've got the gradient. We need the x of that point t and the y of the point of tangent c. Now what we do is very simple. What I want to take is I want to go back to the parabola, which is fx is equal to negative x squared plus 3x. If you get the derivative, it comes to negative 2x plus 3. But the gradient, and this is important, the gradient of the tangent, which is the gradient of the curve, is 1. So let's let it equal 1. Okay, and then we've got 2x is equal to 3. There we go. 2x is equal to 3. Yeah, that would be that minus 2x. So it's 2x is equal to 3 minus 1, should I rather say. Bring the negative 2x across, and then it's 3 minus 1, which is 2. And then 2x is equal to 2, so x is equal to 1. So remember, the gradient of the tangent is the same as the gradient of the curve, which is 1, is equal to negative 2x plus 3. Bring the negative 2x across, and bring the 1 across. So it's negative 2x is 3 minus 1, 2x is 2, x is 1. And then if you work out the f of 1, that would be negative 1. Go to the original equation of the parabola, and let's see what our y value is here. Negative 1 plus 3 is 2. So in other words, the point of tangent C is x is 1 and y is, I'm just going to undo that, do the correct value there, and it's going to be x is 1 and y is 2. Awesome. Okay, so now we know the x of t is 1, and the 2 there would be for the y value. So what do we know? For we've got the x of t is equal to 1, the y of t is 2, and the gradient of the tangent is 1. Okay, so how does the equation of the tangent work? Y minus the y value is the mx minus the x value. So y minus 2 is x minus 1, and y would be x. Negative 1 plus 2 is plus 1. There we go. What a pleasure. Okay, here's a second example, guys. Find the values of p for which this line y equals p minus 9x is a tangent to this cubic. Well, what do we need? With a tangent, we need certain information. And if you remember, we need the gradient of the tangent. That's what we need. We need the x of where the tangent cuts the cubic, and we need the y of the point where the cubic touch and the tangent meet. Okay, but what do we know? We've got a straight line y equals negative 9x plus p. So, in fact, if you think about this carefully, the gradient of the tangent of this tangent line is negative 9. So what a pleasure. So we've got that as the gradient of the tangent. But now, we know that we've got fx. If you take the cubic's equation, negative x cubed plus 3x minus 2. If you get the derivative, that's the gradient of the cubic. Let's differentiate it there. Okay, negative 3x squared plus 3. The gradient of the tangent and the gradient of the cubic is negative 9. And because if the gradient of the tangent is negative 9, it's the gradient of the cubic as well. So we put the derivative equal to negative 9. And we're going to solve for x here. So this gives us 3x squared is equal to 12 if you bring negative 9 across. So x squared is equal to 4. And if you square root both sides, you get x's plus minus 2. So there's actually two values of x for which this happens. Okay, that's very interesting. We'll have to look at it graphically. So, in other words, what we've got is two scenarios. The one is if your x of t would be 2, and there's another x that could be negative 2. Now let's work out the corresponding y values. Okay, so if we go to the f of 2, go to the cubic, it's negative x cubed plus 3 times 2 minus 2, that's the cubic's equation, negative 8 plus 6 minus 2, which comes to negative 4. Okay, so that's going to be the y, one of the y values there. What about x of t? what is the f of negative 2? Well, let's see, it's negative times negative 2 cubed plus 3 times negative 2 minus 2, which is negative 8 minus 6 minus 2, which is 8 minus 6 minus 2, which is 0. So there's another y value here. Okay, so we've got some information. For the one, we've actually got two tangents if you think about it. We've got xt being 2, y of t being negative 4, and the gradient of the tangent being negative 9. Okay, or we've got xt being negative 2, the y of t being 0, and the gradient being negative 9. Okay, so we can get two tangents here. So for this guy, we can say y minus the y value there is the gradient x minus 2. So that's y plus 4 is negative 9x plus 18. So y would be negative 9x, and then that gives you plus 14. Okay, there we go. Alright, now, the other one we've got is y minus the y value is the m, x minus the other x value, which of course is x minus negative 2, which is plus 2. So y would be negative 9x minus 18, if you times in, and that's great, negative 9x minus 18. Now, if you remember, if you go back to this whole thing, look at this. This is the p is actually the y-intercept of the tangent line. So what you've actually got is you've got two values of p. The one is p is 14, and the other one is p is equal to negative 18. Now, what does this look like? Well, if you've got a sad cubic graph doing this, okay, you've got two tangents, okay. The one tangent will go there with the gradient of negative 9, and the other tangent will run parallel to that and also have a gradient of negative 9. So this equation would be y, could be, the minus 9x plus 14. That could be minus 9x plus 14. And the other one could be the other tangent line, minus 9x minus 18. They run parallel to each other. You see, and there's the cubic graph. So there's two tangents for which the gradient is negative 9.